So in this video, I'm going to show you how to convert numbers from binary to denary so we understand how computers count. Before we can do this, we need to understand what we mean when we say binary and what we mean when we say denary. So let's start with binary. So binary is what computers use to count numbers, and we use binary because computers essentially lots of switches that are called transistors, which check or turn electricity on, which we use to represent 1. So 1 means on, and we use 0 to mean off. And you may have seen this sign before, which is the on-off button, which is made up of a 0 with a 1 through the top of it. So because these switches can turn electricity off very quickly and very accurately, it means that computers are very accurate at counting and doing arithmetic. So to explain what binary is, but what is denary? Well, denary is another word for decimal, and we use a decimal number system in normal maths. So that means what we can do is with 10 digits, 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we can use that to make up any number. And because there are 10 digits, we call it a base 10 number system. And that's important because it helps us to work out any number that we might write down. For example, if I wrote down a number hopefully you'd look at that and say that's 43,592. And the reason we know that is because we were taught something called place value quite early on in our education. And we know that starting from the right hand side of our number, we know that this equals the ones, or sometimes we're told it's the units. And we know that the next column is how many tens, then how many hundreds, then how many thousands, and then how many tens of thousands. And from that, we don't even need to think about that anymore. By the time we've reached definitely the end of year 7, we understand that and can read most numbers. What we also know, and we use is in our maths, is that we work out the next place value by multiplying by 10. So if I was to multiply, or I wanted to find out what the next place value was, I'd multiply 10,000 by 10 to give me 100,000. And we can see that here. We've got our ones, our tens, our hundreds, 100,000s, tens of thousands, and 100,000s. So we've got 415,362. And we use that to work out any number. Now, binary is very, very similar. And in GCSE binary, we always have what's called 8 bits. Now, a bit is just a 1 or a 0. So we have 8 bits of 1s and 0s. Now, like denary or decimal had 10 digits and was called a base 10 system, because binary has 2 digits, we call it a base 2 system. And we're going to use that to help us write binary numbers that look a little bit like this. Now, the point at the top about GCSE binary numbers like maths can represent any number, and we can just increase the number of bits that we write until we've made the number that we want, as long as we're only using 1s and 0s. But in GCSE computing, we always write 8 bits. And this is what our binary number will look like. Now, the first thing we needed to work out, which is the same thing in normal maths, I said, is our place value. And that's going to tell us what each column, each 1 and 0 is worth. Now, like in normal maths, we always start on the right hand side with the 1s. But because it's a base 2 system, rather than multiplying by 10 to work out our next place value, we multiply by 2 each time. So 1, start with 1, our place value, always on the right hand side, the same in normal maths, are 1s. Times it by 2 to get the next value of the next column, which is 2, then by 2 again to get 4, then by 2 again to get 8, and then times 8 times 2 is 16, 32, 64, 128, and that's our 8 columns. Now we can use that to help us work out what a binary number is converted into a decimal number that we are trying to work out. So just going to pick any number. I'm just going to 10, 10, 10, 10. Now remember I said that 1 means on and 0 means off. So what this essentially means is, when we're writing binary, is 128 on or off? And because it's got a 1 underneath it, it's on. This one would be off, this one would be on, this one would be off, this one would be on, this one would be off, and this one would be on. And finally, our place value 1 would be off. Now when a computer sees this, this is electricity running down a wire. So each one of these represents a wire running through the computer. And if the computer says that that wire's on, it adds it together to make the number. So in this case, in this example, just rub these out, and I'll rub my wires out. In this example, 128 is on, 32 is on, 64 isn't because it's off, 8 is on, 16 isn't, it's off, it's got 0 underneath it, 2 is on, 4 is off because it's got 0 underneath it, and 1 is off. So because these are on, 128, 32, 8 and 2, I'm going to add these together. 128, 32, 8 and 2. And I'm just adding together the place values above any number that is on. 16, so that's 0, carry the 2. 4, 2 plus 2 is 4, plus 3 is 7, and 1. So I can say that this binary number, 1, 0, 1, 0, 1, 0, 1, 0, just check it's got 8, is equal to 170 in my normal number system. So I'm going to try this example now. So this is my question. Convert this number into denary. Remember, denary means decimal, which is just what I'm used to in maths. So I'm going to copy it out underneath my place value. Just make sure I've got it right. 2 zeros. 1, 1, 1, 0. And I'm going to look everywhere it's on. I'm going to circle. And I'm going to add together the place value. Remember the top row. Above. So I'm going to add 128, 64, 8, 4 and 2. And I'm just going to add them together. So 8 plus 4 is 12, plus another 8 is 20, plus 4 is 24, so that's 26, and I'm going to carry the 2. Now 2 plus 2 is 4, plus 6 is 10, so that's 0 here, and carry the 1, and 1 and 1 is 2. So this number here is 206, so I can say that 1, 1, 0, 0, 1, 2, 3, 0 equals 206. Now what I want you to do now is pause the video, try and work this one out yourself. I'm going to give you let you just pause it, try and work it out. Okay, so what you should have done is copied out the binary number underneath, like so, and then highlighted the columns or circled the columns that are on, and put the place values in your working out next to it, 8, 4, and 1, and added them together. 8 plus 4 is 12, plus 1 is 13, 1, so the answer is 13, and then we can just write out a number. Remember, it's GCSE questions, so we always write out or 8 bits. Okay, so pause this one again and try and work this one out. Good, and what you should have had is this. Copy out the numbers. Oh, actually, sorry, no. What I've made a mistake here is I just wanted to show you what to do, because in this one, there's not 8 digits. So what we have to do here is do this. And add a 0 at the end here to turn it into 8 digits. And we can add these together, circle the ones, and add together 32, 16, and 1, 3, 9. So that's 49. So I can write out 0, 1, 1, 0, 0, 0, 1. Just in case we're ever doing a question that's not GCSE. So what you should now do is go off and try the independent task.